Hey everybody, this is Larry. This is me going Q4 of the weekly contest 350, Painting the Walls. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest and, everything in between. So this one, I struggled a lot with it. It took me 35 minutes. A lot of people did it much quicker. The key part, to be honest, I struggled a lot because I thought it was a sorting problem. I thought there were two things. One is sorting, and by that nature, a greedy problem. And then the other thing, and there are a couple of things that I was going along those lines, like whether it's sorting, heap, maybe even binary search. I was trying to figure out. And the other thing was that N is 500. So I was also thinking about dynamic programming as well. And in the end, it turned out to be dynamic programming, but not in the way that I imagined, to be honest. So, that's what makes dynamic programming very difficult, right? Is that it's a very specific technique, but it's not the entire technique, right? Even within dynamic programming, there are a lot of ways to solve and do different funky things, right? So that's why, yeah. For this one, I was trying really hard to get a greedy solution going, and by that I mean sorting or heap or some kind of thing. But and and I think if you watch the live portion, the part where I solved this live, I think the thought process there is maybe interesting. Maybe I watch it a little bit faster though, because half an hour is pretty long, and I don't do that much all of it. But there are some insights in there that may be interesting for y'all to kind of see how I put because I didn't jump straight into the solution. Even when I got the idea, it's still like I had to debug, not debug necessarily, but like working through my logic through why it was wrong for certain cases and then solving it, right? Yeah, and that said, the and this kind of video, it's not just an explanation video. I'm trying to go over my thought process. Hopefully it's helpful. If not, you're welcome to watch a lot of other videos that will probably just give you the answer and they pretend they knew how to do it all along, etc., right? And some people do, but because some people got it very quickly, right? But for me, yeah, so I think that was the thing. I was trying to figure out basically that almost and this isn't how I thought about it necessarily in these terms while I was solving it, but it was kind of how I was visualizing in my head, is that I was kind of trying to do it as a heap problem, in that, like, okay, you have some bag of things for the paid pointer and a free painter and a paid painter and a free painter, and then try to like figure out how to take out bags and stuff like this. And there are a number of problems that are kind of solved that way. But this one I couldn't really figure it out because I was still couldn't figure out the greedy part, right? And it's not greedy, which is why I couldn't figure it out. Well, even if it was greedy, maybe I couldn't figure it out anyway. But you know what I mean. And and part of that greedy thing, I also try to play around with exchange argument, but because there was sometimes you have to exchange more than one thing, I couldn't really figure it out. Honestly, well, like I said, not a shocker this one because maybe there's no greedy. So the way that I ultimately thought about it was that I kind of noticed the observation that time sub I is only less than 500. For initially, I thought there maybe could be a dynamic programming based on time, and well, it turns out there is, but I thought there was for another reason, right? You can't just do it based on time. You have to figure out why, having that observation and logic and so forth. And I thought that, oh, it doesn't even matter that it's capped at 500 because this could be a million. And almost in a way, they should kept it at a million, maybe. And it would have been okay, maybe. Because if this was I mean, it just takes like another if statement to fix. Because if this was a million, or if this was bigger than n, really, that means that you could use that time to get all the other ones anyway, right? So anything bigger than n is effectively n, right? Or n minus one, if you want to say it that way, like more precisely. So in that sense, it really didn't matter that this is capped at 500, but it kind of led me on down a wrong path for a different type of dynamic programming. So to think that, so the the ultimate observation for me is noticing that time is not, how do I say this in a good way? That time is not like a I want to say cost, but the cost is a thing, right? Time is not something that you use. It's not a resource that you consume. It actually represents the number of things that does not need to be painted, number of walls that do not need to be painted, right? Meaning that, for example, looking at here in example 1, if this time the time sub I is equal to 3 means that 4 rows do not need to be painted. It can be any 4, but so if you take this 4, that's fine. That means that any 4 rows doesn't have to, it doesn't matter which one, just that any 4 doesn't have to be, right? And so if you meet the constraints such that you take a subset of the painter such that n rows are painted, then it doesn't matter which rows they, I mean, if you're minimizing the cost, yeah, it doesn't matter which ones. Maybe I'm saying that wrong. Sorry, but yeah, it doesn't. I mean, you could still backtrack and stuff like this, but the idea is that if you're just trying to minimize it for a unit time, right? Or for all the walls to be painted, and that's basically the idea. And minimizing costs with all the walls painted, and at least a very easy looking solution that is very difficult to figure out. As a lot of, I mean, some of the very smart people obviously figured it out, but it's not easy if you ask me. And you see my struggle, right? So basically, C time is another lingo, but it's basically the number of rows that we can paint, right? So index is basically like a suffix dynamic programming thing where we considered the first index paint jobs or whatever, right? Is it called jobs? I don't know. And this basically just said that what is the minimum cost given that we can paint C time walls and considered index jobs, right? So basically, like we said, yeah. So if we could already paint more than n walls, then this is 0, right? Because, well, we already done all our jobs, so we don't have to, there's no cost. If index is n, that means that, this constraint has not been met, meaning that we are still missing some walls, but we have no more jobs to consider, so that's why we turn infinity. Otherwise, this is just basically, use the paid painter for this job, and this is skip this job, right? Use the free painter maybe, right? And basically what this is saying is that, maybe I'll put it on top. Basically, we add time index plus 1 was painted for the cost of index, right? That's basically all it's saying, and then that's it. I mean, this is a way, like I said, I say simple because look, I took a long time on this one, so I don't mean to diminish it, but this is also a really good example of something that, like, you look at the solution, like, oh, it's easy, it's obvious, it's only like 10 lines of code, blah, blah, blah. But man, is it hard, right? So at least for me. So don't underestimate it, don't overestimate it, don't estimate it. What? No, but yeah, that's all I have with this one. This is n, this is O of n, this is O of n as well. So this is just like, inclusive, exclusive thing. So this is going to be O of n squared time, and of n square space. And that's all I have for this one. Let me know what you think. But before I go, I want to shout out to the problem writer for making n 500 because, yeah, n squared doesn't need to be always like 2,000. I don't know, because Python and the number of test codes and stuff like this. So I just want to give them a shout out for, making a reasonable n because, yeah, I appreciate it. That's all. Anyway, that's all I have for this one. You can watch me solve it live during the contest now. But Leetcode, you never know. All right. That used to be a hard. Now it's just a medium. Maybe it was a hard. I wasn't paying attention. All right. N different words. Okay. One unit of time can only be used if the paid printers. Okay, n is 500. What does that mean? Let's see. No. I mean, there's some sorting involved for sure. Basically, you want the free painter to paint. Is it unit? It is some sorting and then greedy, and then maybe DP after that, but because basically based on some property, the painter is probably minimizing exactly the opposite. So then you have this prefix suffix thing, maybe. I think I just noticed the time is equal to 500, so maybe we could DP on that actually. Maybe that is the way to go. Because basically, I'm thinking of like a heap type algorithm, but as well, but maybe not. What do we sort by? Oh, I think I misread this. So any row in 1 unit of time, so it's not even times of I. Okay. Does that make it easier? Does it give me a greedy perspective? Does that allow me to do greedy in a way? That's the thing with a little bit of a cheating is that, like I don't want to see this during the contest, but it is what it is. Someone already got it though, so that's pretty good. Wow, that's actually pretty fast. But so you don't want to automatically. Can you minimize on? So you want to maximize on costs. So the free dude, is it always cost or is it time? Okay, well, maybe we can think about it backwards, because basically if there's no free painter, then the cost is the total, because we only minimize the cost, we don't care about the time. So then the cost is the total amount, right? So then now we're actually, instead of minimizing, we're maximizing the cost that we're getting, maybe, right? Because it almost doesn't matter, right? It almost doesn't matter that what the time, like it doesn't even matter about the ratio of time, it's just the cost, right? So then basically, okay, so let's say we sort it by cost, and then the free painter takes some amount of that, right? Is there ever a way, let's say cost is equal to 1, you have some like big number, and then the second element, well, I guess only 500, but whatever, and this is 1, right? Or what if this is like 9999? It would still make sense. It's just that we have to be really careful about the order of the painting. What are we greedy on? So if we sort by the cost, the time almost doesn't matter. Is that true? The time matters in that we wanted to maximize for the paid painter, which is a weird incentive, but that's besides the point. But so I'm trying to think about like, what if you have scenarios where you have like, okay, like this is 3 and 5, and then the other one is 2 and even 2, right? But then like, and then maybe you have like a 1 and 4 or something like this. Then technically, you actually want the 3, so that the total cost is 5 instead of, wait, is that even true? No, because if you do this one, then actually it would just cost 2. So you definitely don't want to maximize time. And in this case, you actually want just do the 2. Does it always make sense to minimize the cost then? Because what if we're greedy on the cost, say this, but then you have like 2 and 5, and 1 like, and a billion, right? No, that doesn't make sense. 1 and 4. I guess in this case, we would get rid of these 2, and then we would have 6. Is that optimal? I guess so. Oh, no, because if you choose the 2 and the 5, or 5 and the 2, then it would be 4, right? So you can't just greedily take the min cost either. Because if we just take the min cost for the paid person, the thing is that so it is going to be sorting, but I don't know how to factor that in. That let's say we have this as a greedy thing, but we want to factor this out as actually getting, so this, the cost of this would not be 5, or not only 5, it'll be 5 minus 6, right? And then here it's 2 minus, say, the other 5. But then that doesn't work either, right? So 4 minus 5. Here you would actually take this one first, because then but then that leaves you with a suboptimal solution too. Are people getting this? There's a good amount of people getting it. Me, not so much though. So even if you factor that in, that doesn't quite work. This is a good test case then. But I think I understood this farm correctly, unless I missed it for some reason, because I misread a lot of things. Turns out. Can I do DP? Is there a DP? Because in this case, you actually don't want the free painter to do this, even though it's the most costly. So you can't even, I was wrong about that place. So you can't even just sort it and then be like, okay, well, count from the back maybe. Okay, time supply is equal to 500 makes sense, because then that just means you do one job and it's done anyway. But how do you calculate the impact of this and then just do it in a greedy way? I don't even know how to DP this, do I? Can I DP it on time? How would I DP it on time? Max. Is there a binary search? How would you? Yes, am I missing? No, so okay, so time doesn't even. What is the DP? Is there a DP? So then, what else can it be? What am I trying to figure out? It's not max flow, is it? No, it's not even bipartite matching. Because technically you could match many jobs. Like, and you don't even necessarily want to maximize the time. Though this one, it actually would have been the same, but people are definitely starting to get it. So I'm definitely like struggling a bit on this one. Just missing one inside maybe. It's not n cube, so I'm missing the observation about greediness to. Is it greedy? Maybe I gotta get greedy out of my head, maybe. How would I DP this? There still needs to be some structure if we're DPing it. Okay, let's say we sort it, right, by time. What does that mean? Time and cost, right? Is it a heap thing? Basically, you wanna not. Okay. Maybe it is a heap thing. So basically, with every unit time, I think it's a heap thing. Basically, every time you add in a new item, the max. Is that true? No, man. Because if you take that out, then okay, so if we don't have the free painter, then everything costs the total cost, and the total time is the total time, right? And it's not always optimal to split them in half per se, because you can have like a 500 time one or something, and that'd be very cheap. I don't know the selection criteria. I'm kind of struggling on this part. I mean, even heap is greedy, so maybe that's part of my head. You can process this heap, so then here you have 6, you have 11. If we process this, then it would try to take this, which is, so I'm going in circles. The observation. I think I'm. It's 500 times 500 times. What's log 500? Man, Google is useless on log 500. 9. Is that fast enough? N square log n. Can we do greedy that way? Well, I guess we'll see. I don't even know if it's correct, to be honest. So. And I don't know that you would always. Okay, let's say you have a paint. You'll always cover the max cost. Okay. Yeah, that makes sense. Actually, do you? No, maybe not. But let's say you stop there, then you have to cover the rest. Right, so then now you pop out another one. So which one is the painter painting though? That still isn't answered. I mean, you have an implementation, but not the theory. Can I take advantage of times of I 0 to 5? I mean, that's just n, right? That's why. Oh, is it like an if statement problem? It's an either or. Okay, so here, if we do this, I really have no idea. Yeah, I don't. I mean, not a lot of people have gotten it. Don't really have any ideas. This is the case that I don't think I can figure out how to greedy for. Is there an exchange argument? What is the exchange argument for this one, for the sorting? Because now you're exchanging multiple items almost, right? this costs 2 and 6 together, so you want to do this instead, that's fine. But then how do you sort these two then? I just want to do this one. So then you would look, if you do exchange E, and the full one is after that. And how do you put the 5 2? 5 2, 5 will look at the biggest two elements. So this sort key is what, 11, this is 9, this is 7. But then this doesn't factor in the fact that this kills 3 jobs, right? Instead of, okay, so time sub I is equal to the number of jobs plus 1. Does that give me any insight? For example, this means that 3 jobs for 5. It matters what jobs they are too, right? Is there a sorting thing? Because you can always just have like a 2 and a million, and then that'll be 2. Or this is a 1, then you want this one, right? So is there binary search? Or even just a loop? 500 times 500, what is that? Oh man, my computer is crashing at the most. I mean, it's not crashing, but it's, where's my calculator's not coming up? So 500, now I have to use my head. 500 times 500, 2,500, but, or 25,000, or 250,000, I can't even say it right. Right. So now I forgot what I was doing. So then now we can iterate on, okay, we're spending X amount of time. How much can it cost? Can we DP on that? So then that's already n squared though, but n squared plus, so let's say we do, what's the minimum amount of time that we need to spend? So that's at least half, probably. What's the minimal cost? We do DP now. What's the minimal cost that takes 2 time? Give it 2, and 2 is 5. So what's the, where do I get 250,000 from? I mean, I get this n squared, but n is at most, or time is at most 500, right? So then here we're trying to minimize the cost. Of it taking 2. But what does that even mean? Is 2, so if we take half the time, is it always enough? because of the pigeonhole principle, that's true, right? So is it just DP? Is that the observation? Time, right? So let's say minimum cost for time, maybe time in index, right? So if time that means that we're already done. We can skip all the rest, right? Otherwise, we can either do it or don't do it. So it's time plus, this is terrible. So C time maybe for current time. Total time? I don't know. Plus times of index. Cost. So then now we're minimizing this. If index is equal to n, then we return. So we use ordered things, but C time is still so then infinity, right? That's a really hard observation for me, to be honest. I don't know that this is right, but I've been doing nothing for a while, so right. And then now for I in range of n divided by 2 minus 1, maybe something like this. Or I guess you could just write like this, just round up to n. And was it? I don't know that this is right. Oops. Intent list. What? Line am I talking about? 20? C time plus time, plus cost of index. Whoops. Well, I mean, that's pretty good if true. Dun dun dun. Oh, whoops, this isn't right. This is. Oh no, I'm counting from 0. But this should be n over 2, maybe? Maybe that. I kind of confused what I needed. I've kind of constructed this backwards. 2 and 4, that's clearly not right, but maybe I needed this. 2 is still not right, because okay, so the total time, let's see, so there's 4 items, so you want the time to be 2, and of course the best for after 2 is, but then the actual time is 3. What is wrong about my assumption about 2? 2 is that it's 2 plus 2 others. Oh, I see. This is wrong because I don't count itself. So, okay. So then now we just have to maybe change this up. I don't know if this is right though. I mean, this fits the thing, so let's give it some. I'm not very confident about this one. But okay, well, that was a hard one. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this explanation or this contest in general. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.